Bismillahirrahmanirrahim. Dear viewers, now we will start our next part for 3 storied building design course. So let's start with plinth beam. Here we will select all the plinth beams like this. Then we will deselect the beams which is not having wall load like this. So we will calculate wall load. Here wall width 20 cm, floor height 3.6 meter, top beam depth. There are different size of beams are available. So minimum depth of beam we have provided 40 cm, so that one we will provide. So this unit weight for this hollow block 1450 kg per meter cube, in kilonewton per meter cube it is coming 14.225. So line load from wall it is coming 9.1 kilonewton per meter. So we will apply here dead load and live load predefined. So in that case add another load pattern. We can add this wall load and floor finish as dead load, but if we want to check structural self weight, then in that case we have to apply those floor finish and wall load in separate load pattern. So I will add here SDL superimposed dead load like this. This self weight multiplier, in this case we will keep 0. Self weight multiplier for structural self weight will be 1 like this. So click on OK. Now here from here assign frame distributed load SDL 9.1. click on apply. Go to next floor. Here select all the beams in this way. Here there will be no wall. We will apply SDL 9.1. Here other floor as it is 3.4 meter, so we can reduce our load 8.53, or we can apply 8.55 kilonewton per meter. Apply. Now here we will apply our floor finish and sand filling load on sunken slab. So now select all the floors. Then here we can add assign shell load SDL floor finish 2 kilonewton per meter square, live load 2 kilonewton per meter square. Here we can click on PS, that means previous selection, then it will select previous selection, then live to apply. Now for sunken slab areas there will be additional sand filling load, so we will select those slabs from here. This one, this, these two. Here we can add here 3.6 kilonewton per meter square additional load. In that case we can click on this add to existing load. If we want to replace existing loads, then we will apply 5.6, that means we have provided floor finish 2 plus 3.6, that means 5.6 kilonewton per meter square. So any one of them we can choose. Close this one. Now here as there will be additional load for stair, so here for inclined slab we will add additional load 3 kilonewton per meter square. Click on apply. Now we will select all the structural members of this floor and click on replicate. Go to story, first floor roof and roof. Click on apply. Now we will go to first floor roof. Here we will see the sunken slab. Here there is no sunken slab, so here we will change this one. We will apply SDL floor finish only. Click on apply. So other sunken area will be same, only this area changed here because of this drop beam. Now in roof, go to roof. Here there will be no sunken slab. We will select this level, then click on this SDL. Here SDL will be, or floor finish will be 3.5 kilonewton per meter square. In roof, floor finish will be higher than the regular floors because of thick layer of waterproofing and tiles in the roof. So here I will add 3.5 kilonewton per meter square. Now click on this. As live load will be same as it is 2 kilonewton per meter square. Now we will go to wall load. Wall load, here it will be 0 because on top of this there will be no wall. Only we will select the periphery for applying parapet wall load. Parapet wall load usually consider 4 kilonewton per meter. Click on apply. If we want to remove this extra line load, because only periphery there will be parapet wall, then we will split the lines or break the line. Yes, break at intersection like this. Close. Here this portion and this portion we will provide load as 0. Now these two we can merge. Like this. Now we can see this load applied on peripheral lines only. So our load application also finished. Here we will change this hidden beam. (20/60) because this hidden beam only in ground floor roof. For first floor roof and roof, this will be 20/60. We can view our model in different colors and extrude view also. Go to here, view colors of section properties, apply. Here click apply, section properties, apply, like this. Here stories also like this. We can see in extrude view like this. Frame design type like this. We can remove grid from our view by clicking on set grid system visibility. Again, if we want to bring back grid in our view, click on this, it will come. Now we will apply loads in robot structural analysis. Now go to load type. This one dead load DL1, or we can write here self weight SW, add. This will automatically consider the self weight of structural elements. Now we will add number 2 SDL as we have defined in Etabs. SDL, click on add, and third one live load LL add. Now click on this because we will start with SDL. Close this one. From here also we can go to this tab in this way. We can choose our loading type, then we can apply our load. I will go from geometry. So now load definition, here case number 2 SDL, so it will be bar this one, so minus 9.1. this load will be applied. Here I'll go to plane beam, I will select all the beam, then click on add, click on apply. Now here if we want to see loading in this side, click on this loading value, here 9.1 kilonewton per meter square applied. Here we can click on this window like this, right click, load properties, here we can make it 0, click on add, here only for the indicated one, click on OK, and here also click on this load properties, click on this 0, add, click on OK. Now these two beam released from the wall load. Now we will go to ground floor roof. Here we will select the beams in this way, then we can click on control this to remove from the selection list, then we can go to load definition bar. Here for ground floor roof our load is 8.55 minus 8.55, click on add, then this bar list, click on apply. Okay, now go to load definition surface, this one, here provide floor finish 2 kilonewton per meter square, click on add, select this floor like this, click on apply. We want to add sand filling load extra 3.6 kilonewton per meter square. So to do that one, here we will see our loading. From here we can remove our line loading symbol, go to right click, display, here load symbol, from here linear load symbol we can remove, click on OK. Shift and middle of mouse you can use to rotate the structure in this way. We can click on this, right click, load properties, here we can type 5.6, click on add, only for indicated one. Click on OK. Select other loading also. Load properties 5.6. Add. For the object selection, select this one, this one, this one, this, or from here we can select this one, this one. So click on OK. Now we can see here the loading changed for selected areas. Now this one we will change to 3 kN per meter square for stair portion. Add. Click on OK. We will go to load definition. Here case name SDL. This one we can change. We can click on LL, live load, then go to load definition, go to surface, click on this. Here we will type 2.0, add. Now select the floor, click on this box, then click on apply. Done. Here in this view we can see this one. Here you can see 2 kN per meter square live load. So now we can replicate our story. We can select all of this story, GF roof. Now right click story, copy contents of the story, click on this above number 2, click on OK. So our elements copied to other floors. Now here we will go to first floor roof, this one. Here click on this window, then story, filter structure storage, like this. From here we can edit our loading. This is live load. We will change it to SDL. Now here you can see this load 5.6. We will change it to 2.0. Add only for the indicated one. Click on OK. This ends in first floor roof. So this beam we will change it to the section 20/60. Now here story, click on this to unfilter the story. Now go to roof, filter the story. Here we will select the load properties. Here we will edit this 3.5. Add. For the object selection, click on this roof. Here select the floor, click on this, then click on OK. Now all the slab loading changed to 3.5 kN per meter square. For wall loading we can click on this. Now display, here load this planar load symbol, click on this, apply, OK. Now here this load we will change load properties, we will make it 0. Add. Now for the object selection roof, here click on this, then click on the box, click on OK. So now load removed from the beams. Now we will go to load definition, SDL bar. Here we'll add 4.0 kilonewton per meter for parapet wall. Add. Now we will select the beam, this one, click on this, select the beam, like this, click on apply. This one, select bar 4, add, apply. If we want to apply partial wall loading on this beam, because only peripheral portion we will apply the parapet, so select this one, click on this bar, this type of loading, trapezoidal load, z direction minus 4.0 kilonewton per meter square. P2 also same, absolute distance 4 meter. From here we can see from this grid to this grid 4 meter, and this grid to this grid 5.2. so x1 4 meter, x2 5.2 meter. Click on add, apply to this 431 number beam, click on apply, close. Now we can see partial loading applied. Same here for this beam, here to here 3.2, here to here 6.8. now select this one bar, this loading value minus 4.0, absolute distance here 3.2 and 6.8, 3.2, 6.8. click on add, this one, apply, close. This full loading value also there, so this one we will delete, add, click on OK. Now this partial loading is there. Now this load also we will delete, that means we will make it 0, add, click on OK. Now here we will check the distance, this grid to this grid 1.8, this grid to this grid 3.8. now select the beam bar, this one 1.8, 3.8, 1.8, 3.8. click on add, apply. So as it is going in this direction, so we will undo this one, as it is starting from this side. So select the beam, click on this bar, this one for absolute, so this one will be 0 and x2 will be 1.8. so add, apply, OK. now this partial loading applied. Now here Storied, filter Storied, this is done. So our modeling up to third floor finished. We can see these colors for different Storied. Go to display, mark with color by section color. You can see like this, we can see by Storied clicker like this. Now save this model. Now we will apply load in ground floor roof. We'll select the slab properties. Here we can see there is load. Dead load we will provide 5.6 and live load 2. Then click on update. Okay, now in this way select this one, this one, this one, this one, this one and this one. Right click, properties. Here I'll click on this. Here write 5.6, press enter. Then here live load 2, press enter, close. Now we can see here properties, here load 5.6 and impose load, that means live load 2.0. Now balance this one and this one. We will provide the value 2, press enter, live load 2, press enter, close. Now this one we will change it for dead load 3.0, update, close. We will select a beam, edit beam wall load. Here we can provide the wall unit weight. Here wall unit weight 1450 kg per meter cube, that means 14225 kilonewton per meter cube. Per meter square it will be this one into 0.2 width of the block, width of the wall, so it is coming 2.845. This one will be 2.845. So here you can see 9.1 kilonewton per meter. Click on OK. Now this one, copy beam wall load. This one we will select all the beams, then right click, paste copied beam load. Yes, like this. This wall load we will change, edit beam wall load. Here this floor height 3.4 meter minus 0.4 meter of beam depth, so 3.0, then it will be 8.55 kilonewton per meter. So to make it 8.55 we will provide 3.02 meter. This is going larger, 3.01, 8.56, 3.007. So now it is 8.55 kilonewton per meter. Click on OK. And this, copy beam wall load. Now select all the beams, right click, paste copied beam load. Yes, like this. We will edit this wall load. This will be 0, 0, 0. Okay, and story 1 here, this and this, edit beam overload, 0 0 and 0. Click on OK. So this is done. Now we will replicate our story or copy our story. Go to building setout, generate story, this is story 3, and click on press Ctrl and click on story 4. Source story, this is story 2. So then member type to be generated, all the things, click on OK. Yes, close this one. So this is done. Now we can go to story 3. This one will be changed, properties 200 by 600, update, and this load will be changed 2.0, update, done. Now go to next floor. Here this one 200 by 600, update, close. Now here all the wall load, you can delete beam wall load. Yes. Now we can select the beam, edit beam wall load. We will provide unit weight 2.845, wall height 1.5 meter, 0.2. So as we have used 4.0 kilonewton per meter, here we can change the height 1.4, 3.98, 1.41, 1.405. Now it is okay, 4 kilonewton per meter. Click on OK. Now this copy beam wall load. Now select the beams, paste copied beam wall load like this. Now here this portion, we can select this one, define beam wall load, click on this, then from this point to this point. Here we can see edit beam wall load, here 4 kilonewton per meter. So click on OK. Same here, this one, define beam wall load from here to here, and here define beam wall load from here to here. So now our parapet wall loading also done. Here also we can select the slab table. Here we can type dead load 3.5, enter, live load 2.0, enter, close. S12, 3S15, this 12. So here live load not applied, so I will select all the slab, and this one will be 2.0, 2.0, close this one. 13 we will check, this is 13. Story 2 also, we will select slab, here 2, 2, 2, 2, close this one. 3-storied building modeling with loading finished in Pro.This structure also. Now save this one. Here in Tekla structural designer we have to keep columns continuous up to roof level so that we can copy only beams to define floor level. Select the column structure up to top, like this. Select all of this. Top level will be 4. Now we will apply load. Loading. Here load cases, self weight, slab self weight, dead, live, roof live, snow. We don't need snow here. We'll delete this one and we will use same live load for all the floors, so we can delete roof live also. Now click on OK. Here we will select dead load. Here we will change it to 3D view, then go to full UDL 9.1 kilonewton per meter. We will select the beams. Here in Tekla structural designer you have to apply load by selecting beams separately. You cannot apply load to all the beams at the same time. If there is any other way, you can mention in comment below this tutorial, because I did not find any way to apply wall load at the same time for all beams. Now we will go to ground floor roof. Go to 3D. Here select dead load, full UDL. Here 8.55, enter. Now here we will apply area load. .6 here and 2 kilonewton per meter square here. Now this slab and beam we will copy, edit, copy from here to press F2 for 3.4 meter. Click on enter. Done. Now level, go to level 3. Here 3D view. Here again we need to apply load separately. Full UDL 8.55. Now here this beam we will change section 200 by 600. Here area load 5.6. load live 2 done. 3 also finished. Now go to level 4. Here we'll select the beam, edit, copy. Here press F2, 3.4, enter. UDL 4. Now for partial wall loading, click on UDL. Here 4 kN per. Here to here. Now from here to here. From here to here. Now partial loading done. Now area load. This dead 3.5. Like this. Done. Now for live load 2 kN per meter square. Done. Now our modeling up to roof level with loading finished. We can change the color of structural members. Scene settings, here we can change the color. Concrete beam color, we can change it to different color. Green, this color, click on OK. It will look like this. Now save the model. Dear viewers, now we will apply loads and we will finish the model in Staad Pro. Now go to loading, new load case, dead, DL, add, live load, LL, add, close. Now dead load, add, self weight, add, close. This one select, assign to view for whole structure, yes. Now select DL, add, member load minus 9.1, add minus 8.55, add minus 4 for parapet wall load, close this one. Now here we will go to view this side, select all the, go to replicate along y direction 3.6 meter, like this. Select all the nodes like this, then move nodes downward 0.2 meter because first floor height is 3.4 meter, ground floor is 3.6 meter. So this will go down 0.2 meter. Yes, like this. 8.8, 1.8, 3.6, 5.4, then 3.4, 8.8. Close this one. This one length 3.4. Okay. Now we will go to geometry, view. Here plate or slab, not replicated. So go to this side, select plate cursor, select all the plates, then go to replicate, y direction 3.4 meter, click on OK. Now plate replicated. This side we'll select all these elements again, replicate, y direction 3.4, click on OK, and select plate from here, replicate, y direction 3.4 meter, click on OK. Now save this model, go to loading. So select 10 beam levels, right click, new view, click on OK, select all the beams, then press Ctrl to deselect the beams, assign to selected beam, yes. Now view, side view, select ground floor roof beams, right click, new view, OK. Here loading 8.55 kilonewton per meter, select all the beams except this one, assign to selected beams, assign, yes. View, this one, new view, now go to property, close this one, 20/60, this one, select this and this, assign to selected beams, yes. Now line load or wall load application finished. Go to loading, view, this side view, select plate cursor, right click, new view, click on OK. View, here dead load, we will add plate load GY minus 5.6 kilonewton per meter square, add 2 kilonewton per meter square, add 3.5, add, and 3.0 for stair portion. Close this one. Now 5.6, use cursor to assign, like this. Okay, now this one, now live load, add plate load GY minus 2 kilonewton per meter square, add, select this one, cursor to assign or assign to view because it will be assigned to all the plates, assign, yes. Now geometry, view, this side, now I will select this plate. View loading. Now we can check our loading. Self height we will assign to view. Yes. This one clean beam. Wall load. This one ground floor roof. Here first floor roof we have not assigned, so we will select this first floor roof also. This one we will select, then new view, click on OK, like this. Select this one, select all the beam except this one, assign to selected view, assign yes. This one ground floor roof and first floor roof. This for parapet wall. This one for ground floor and first floor roof. This one for ground floor, first floor. This one for roof, and this one for stair portions. Now live load for all the floors 2 kN per meter square. Here we can go to geometry, view, first floor. Here select plate cursor, this one, new view, OK. Here loading. This area, this area, this and this area, and here last one, this area is having one-way load distribution, so we will remove this load from these portions, this one-way regions. This load we will delete. Now we will add new, here plate load minus 5.6 GI, add, click on this. Now here select the plate, this one, 5.6, yes. Now these portions we will add floor load for one-way load distribution. Now go to add floor load. Here we will write the ranges for this area. For example, here we will see, select node cursor, this y 5.4 meter level, x 0, x 2.2, 2.2. This is little bit lengthy in Staad Pro. Applying one-way load, applying one-way slab load. Now this one Z 5.2, Z0 to 5.2. Okay, now go to add floor load, Y range, this one 5.4 to 5.4, define x range 0 to 5.2, no, 0 to 2.2, z 0 to 5.2, and pressure here 5.6 kilonewton per meter square. Add we'll select one way load distribution, modify, okay, geometry, loading. Here we can see one way load distribution. Go to geometry, view, this side, right click, new view, click on OK. For this portion we will select the node, this one, this one, loading, now balance roof floor, one way load 3.5 kilonewton per meter square. So now our load application done and modeling has been finished. Save this one. We can see the structure diagram, full section, fill plate, close.
Press the bell icon on the YouTube app and never miss another update.